Hello.
Hello.
Yeah, hello. Yeah, good evening.
Good evening, sir.
Yeah. So total cards 6, which is mostly combinations. So share my screen. So is my screen visible?
Yes.
Oh,
Yes, sir.
Yes, sir.
so okay. Let me just give you a brief about what uh what is what are we going to cover and what have been covered. So this week 5 and week 6 are on based on permutation and combination. So Mm. So in this basically few things comes like counting, how to do counting and all. Like there are like uh, and and or way. So if there is a event happening and then another event is happening, then we multiply it. Uh, and like another case is like if one event is happening along with another also is happening. So and anyway, it's possible. So that is like addition you do. Okay. Then we covered what is factorial. So factorial is n factorial denoted like that. So this is just a multiplication of n into n minus 1 into n minus 2 till 1. Okay, till 1. Uh, and 0 factorial is also 1. This will come when you use combination and permutation, NCR and all. So that is like next is yeah. So actually, what does this factorial mean is factorial meaning arrangement. Okay? Arrangements. So whenever a question is about arrangement, then uh, then you should know that you have to use factorial. Okay. So one of that application is permutation. Okay? One of that application is permutation. So in that, what we do is we have uh, n number of objects. Then the question is how to select. So in this, there are two things: select and arrange. Uh, are things. So select and arrange are things is what we do in permutation. And let's say if I have let's say I have 5 books. Okay, 5 books. Let's say history, mathematics, physics, chemistry, biology. So these 5 books are there. The question is uh, how to select. And let's say I have a bag in which I want to keep it. Okay, I want to keep this in this bag. So select 3 books and arrange in bag or something. Okay, so in a linear order. So linear order. So that is like permutation. And let's say so 5 is there, and I need to select 3. So like 5 factorial divided by 5 minus 3 factorial, which is 2 factorial. Right? So that's how you do it. And that's what the factorial itself also means. So let's say when I say n factorial, that is like n. It's the same as npn. Okay, npn. N factorial is npn. So if you see, like, the formula will be n factorial minus n minus n factorial, and that will become like n factorial. And this is 0, right? So 0 factorial is 1. So that's why this n factorial will come up. So basically, factorial means
Kylie,
arrange all the all the things, right? So basically, we are selecting all the things. We are selecting all the elements or all the objects. It's selecting all and arranging all also. That's what factorial means. Okay. Then I think there is some. Is there any doubt? Okay. Okay. So that's what.
Could you please explain once?
Explain again.
Sir, I guess someone is on mute.
Yeah. Can you mute yourself, please? Shri Niket Rajesh. Okay. So you see,
Sir, could
factorial
you
is
please,
arrangement.
sir, could you please announce again?
Sorry.
Could you please explain again? Understand?
Yeah, that's what I'm doing. So factorial is arrangement. Okay. So when question is how to arrange these things, okay, arrange all the things. That's when you have to use factorial. Okay, so that is like let's say n factorial, anything. So whatever number is there, say like you have n objects, so you will arrange them in n factorial ways. So let's see. So let's say I have three books. Okay, three books: history, physics, math. Okay, these three books are there. Arrange them. So how many ways I can arrange them? HPM, HMP, then M or P, HMPMH, then M. So that will become HPMPH. So this six ways I can arrange them. So see, you can see all the six ways are different. So this six ways I can arrange them. And this will come like another way to do is let's say I have three things I want to arrange. Okay. Uh, and I have three objects also. So three books I have in this case. So three books are there, and I want to arrange in three slots. So you can say this is slot one or something. Okay, uh, slot two, slot three. So how many options I have out of three for the first place? All the three, right? All the three are there. So I'll write three. Then in the second place, since one is chosen, so I have two options left. So uh, then I can choose only two things. Okay, and then one thing. So if you multiply this, you will get six. So both ways it's the same thing. So arrangement, whenever arrangement question is there, either you do this way or factorial way. So but factorial ways is the easier one. Okay, that you have to arrange all the things. Okay, and factorial ways, and keep in mind that all the all the uh, objects are distinct. Okay, so if they are not distinct, uh, if they are not distinct, or there is a something repeating. So let's say now I have two history books. Okay, same thing. Everything is same about them, and I have one math and one physics book, and I want to arrange them. Or let me not take this one. Okay, so let's say I have three only. Now if I want to arrange them, then the formula goes like n factorial divided by the group one, any group. So you can say this is a group, okay, because they are same thing. Whichever is same, you can call them as a group or um, any group. We'll call them group, okay. So something like, so it goes like G1 factorial, G2 factorial, and all. So since we have only one only, like G1 only, like if there are multiple, then you can go up to whatever it is, okay, up to Gn. So any number G, K or something. Okay? So that's how this goes. So let's say if I want to arrange them, then it will be 3 factorial, uh, and divide by, so this is a group, so that is 2 factorial. And you can write this also like 1 factorial. It doesn't gonna make any difference, since this is also a group, right? So of a 1. And we know the 3 factorial is 6 from this, and divide by that is 2. So this is 3. And if I arrange them, you can see that I can arrange them HHM or HMH or MHH. No other possibilities. Uh, there's no other way I can arrange them. Okay? So this 3 only possible because of repetition. Right? This 2 are same. So let's say what I'm saying is H1. I'm just giving name H2M is equal to H2 H1M. Correct. So that's why I have only one thing available now. And same thing here. If I say let's say H1 MH2 is same to H2 MH1, and same thing here is I have M H1 H2, and let's say M H2 H1 H1. So this all 6 cases. I mean, not 6, but this 2 are same cases. This 2 are same, and the next 2 are also same. That's why we only kept one of that, right? One side of that. That's like uh, giving you a visualization. But this is the formula you have to use when there is arrangement and objects are not distinct. Arrangement, very specific arrangement. When choice is given, choose this, then not to do this. Okay, because choosing. So now the next thing is choosing only. How to choose things. Okay, that is combination. So I kind of remember like choose is C and combination is also C. So maybe you can do that as well. So combination is how to choose uh, how to choose R objects from N objects. Okay, N objects. It doesn't matter they are distinct or not. Maybe let's say all 3 are red. Okay, let's say all 3 are red balls or something red. And I'm saying choose any 2. So that is like 3C2. Okay, we'll see what is that is, but it doesn't matter. See, if I let's say choose now let me give a name R1 R2 or R1 R3 or maybe R2 R3 uh, like that. So what is 3C2 is? First let's see what is how to decipher 3C2. Then I'll write the cases. 3C2 is like 3 factorial divided by okay, NCR is N factorial, then N minus R factorial, and you will divide it again by R factorial. Okay, so NPR is, I'll write again here NPR, which is previous one, in which it was N factorial, N minus R factorial. That's all. Okay, there was no this one. This part was not there. Okay, so this is choosing. This is choose and arrange. Okay, arrange, and then there was factorial. So N factorial, which is arrange. Okay, so which is arrange. So you kind of get the idea that you know this two can form this, right? This is arrange, this is choose, and this is choose and arrange. So if you write that, and is multiplication. Okay, so choosing is like NCR. Then if you multiply that with n factorial, you'll get NPR. Okay, that's how you get this. And you can maybe solve this as well. So n factorial into n minus r factorial multiply by r factorial. So okay, the issue is I have only r objects, so not n. I have to multiply. I have to uh, do r times this. Right? Only r objects are there. I want to arrange them. So that's why r factorial, not n factorial, and that is np, and this will get cut off. So okay. Now in this case, let's say I have three objects, they are all same. I want to choose any two. Then the way to do is like 3C2, right? So that's the 3 factorial, 2 factorial, and 3 minus 2 factorial multiplied by 2 factorial, something like this. So uh, we know this is 6, this is 1, and this is 2. So that is 3 cases, right? So like, either you can choose R1 or R2, or you can use R1, R3, or you can choose R2 or R3. Okay, this three only possible. Nothing else is possible. So that's what choosing is. So so whenever you get a question of choose this, just choose. Okay, so you have to use combination. There is like choose and
Yes.
arrange. Okay, then I'll use permutation. Okay, so let's see a question. Say how to arrange letters in a word. Uh, let's say word is table. T, T, L, T. So these are the letters. So in table there are 5 letters. There's 5 letters. Right? I want to arrange them. So arrangement is like table itself is arrangement. Then like TABEL. This is also arrangement. So these two are different, right? Um, and let's say so if you say TABLE is different than if I write ELBAT, which is opposite of this, if they are opposite. So these two are different uh, different arrangement, right? So uh, so how will you do that is this there are like 5 choices, 5 objects, you have 5 elements. So these are 5 elements right now, or objects being called. So that is you have to just arrange them, all of them, right? So there is like 5 factorial ways, and that is 120. And you can see other ways. Let's say I have 5 spots available. At first spot I can choose any number, right, out of 5. Then at the second spot I have 4 left. So that is 4 I can choose. And at third I can choose any 3 because 3 left. And that's how also if you do that is 5 factorial, right? And 120, which is also 1. So any way you can solve it. Arranging is uh, that way. So now let's say I want to arrange uh, TATA. Okay, this is a uh, word of which all the letters I want to arrange. Now there is a repeating thing, right? So this is like you can call it as a group or something, repeaters. So in this case, I can arrange 4 factorial ways to all of them, but then I have to divide this a since it is repeating twice. So that is like 2 factorial. Okay, so 4 into 3 into 2 factorial divide by 2 factorial. That is like 12. Uh, or you can call this as n uh, 4p2. Yes, like 4p2, which is like 4 factorial and 4 minus 2 factorial. So same thing, 4 factorial by 2 factorial. Okay. So but see in this case, this 2, right? Why I chose 2 and not any other number? I uh, I kind of get the idea from this one, but I didn't get the idea from this one that I have to do this. Okay. So I mean when to use permutation and combination, or like factorial, you have to think in a way that what is the question is asking. It is asking about arrangement. So I'm sure that either factorial will come or permutation will come. Okay, permutation will come. So in permutation, I know that when some selection I have to do, then I can use this some selection. Okay, but here I need to arrange all of them. So selection is not required. So I'll just use factorial and try to solve this. Okay? So something like you can think, and then you can solve this. So let's say if I have a word which is say, uh, bookkeeper, book keeper. So this is a word or something, and you want to arrange all the letters of this, all the letters. Okay, so you want to arrange them. So how many ways you can do it? So first you need to create a how many are there, right? Counts of it. So book is coming out to be ones. Then let's say O is here, here, and that's all. So I'll write O as two. Then let's say K is two, and yeah, that's a K is two also. Then say if I say E, there are like three E's. Okay? And and then let's say P is there. So P is coming to be one, and then there is R. So if you see that the total of this is 1 plus 2 plus 2 5 plus 3 8 9 and 10, right? So total 10 are there. You can count it 1 2 3 4 5 6 7 8 9 10. Okay? So I can arrange all of them in 10 factorial way, correct? But then there are like groups forming or same object, same element is coming, repetition is there, right? So now this is a case of repetition. In case of repetition, I need to divide it by this also, right? I'll write 2 factorial, 2 factorial, 3 factorial. Okay? And whatever answer comes up. So maybe you can solve this. Okay. Now, okay. Now let's see a case. Let's say I have uh, four red balls. So these are like balls, okay? For four, so maybe this four red. Then I have, let's say, uh, three green. Okay? Three green. And maybe let's take yellow. So I have yellows as two yellow. So this all balls are there. And what I need to do is I need to um, select any three balls. Okay? How many ways I can do it? Just the selection. So uh, in selection, we it doesn't matter which color is there. Okay, we will just count how many balls are there. Let's say I want to select. The question is how select three balls. Okay, this is the question. So how many total are there? 4 plus 3, 7 plus 2, 9. And out of 9, I want to select 3. So this is the answer. 9 factorial, 6 factorial, and 3 factorial. You can solve this. You will get 9 into 8 into 7 into 6 factorial divided by 6 factorial into 3 factorial. So 6 will get cut off. 3 factorial is 3 into 2. So if you write 3 into 2 and 2 here, 3 is 2, sorry, 4. So answer is 3 into 4 into 7, which is uh, 4, 3, 12, 12 into 6, 84. Yes. Okay. And okay, now the question is, now let's say question is select three balls such that such that at least at least one uh, at least one, okay, one should be red. Okay, at least one should be there. So now this is a question given to you. So like it's a little bit different than what we were doing till now. That we were just selecting or arranging them, right? But now the condition is at least something. So in if you see at least, if you see at least somewhere, or at most is the another one, then you can solve it in a different ways. You can write like how many total ways are there. Okay, so total ways we know NC3. This is the total ways to select three balls. Okay. Uh, Now what will be the another cases? So total ways is select at least one. Okay, at least one red plus select. What would be the counter of this? Okay, what would be the counter? So if I draw a Venn diagram or something, let's say I have this three balls or something. Um, okay, total ways. Then select one red is there. Something. So what would be the complement of this? And what is the opposite of that? Select at least one, right? So okay, Venn diagram will not work, but um, okay, in three. So then there's three. At least one red should be there, right? Or the another case is there are two reds. Okay, two reds in this, or at least means all the three are red, right? So this all possibilities are there, right? So this three possibilities are there, right? At least, and the opposite of this is there's no red ball, right? No red select. So either you can go and do this. So um, and you can add the cases, right? That let's say at least one. Huh? Sorry. Okay. At least one red. Okay. So in this, there are three cases happening. That either okay, either you do this case, or this one red, two red, or three red. Okay. So if you see first one, how to solve that is I have four reds, and out of that I want to select one only. So that is 4C1. Then I'll multiply and I'll select other two, right? So other two can come out of this uh, anything, any green or yellow, anything, fine, right? So that is like 5C2. This is at least this is first case, one red and two anything else. Then another case is two reds, right? So 4C2, and out of five I'll choose one. Then the last case is I'll choose three out of this, and nothing out of the five, right? So these three cases, if I add them up, it will be like 4 factorial into 4 minus 1 factorial, which is 3 factorial into 1 factorial. Okay, this is 5 factorial, 5 minus 2, 3 factorial into 2 factorial plus 4 factorial, 2 factorial, 2 factorial, 5 minus 1, 4 factorial into 1, and plus 4 factorial, 4 minus 3 is 1 factorial, and 1 factorial, 3 factorial, multiply by 5 factorial into 5 minus 5, which is 0, and then 5 factorial. So this is 1, right? This case is 1. Okay. So if we solve this, you'll have 4 here. Then in this case, you'll have 5 into 4, and that is 10. So this is 10. Okay. This is 4. Plus, if you solve this, that is 4 into 3, and you cut out that, and then 6 is there. In this case, it is 5. Then in this case, it is 4 into 1 into 1. So these three cases are there, and that will come out with 40 plus 6 5 is 30 plus 4, and that is 74. Okay, so 74 uh, ways you can choose uh, three balls such that at least one should be red. Okay, so then why I wrote this, how to do this way. Uh, in this case, do is I know how to select total with how to select three balls out of all, and I can solve this part. No red ball should be selected, which is very easy, right? Which is very easy. 5 out of 5, choose all the three. That this is no case, no red ball. Then I'll subtract out of total ways. So okay, so total ways is equal to at least one red plus no red ball. So uh, no red ball. Then I can let's say this is P. This is right. Let's say if I write R, then this is like R kind of complement of it. Okay, this is the way you can do it. So if I want to find R, I can minus R complement. So total ways to select is 9C3, right? Which we did here. Mm, This right 84. This is 9C3. So this is going to be 80. And no red means I have 9 balls. Out of that, 4 are red. So 5 left. Out of 5, I will choose all the three. Correct. So if you do this, this is 5 factorial. 5 minus 3 factorial, which is 2, into 3 factorial. And if I solve this, this will be I'll solve a 5 into 4 into 3 factorial divided by 2 into 3. So this will cut off, and 2 factorial is 2 only. So this is 10. Right? So 84 minus 10 is 74, which is our previous answer. This right. So both way you can solve it, whichever you feel easy. So this in this case you have to remember all the cases. You might miss something, possibilities there, but this way is much easier. You just need to you just need to find what is the complement or what is the opposite of something is happening, and you can subtract out of all the cases. Okay, so sometimes direct solving will not help. You have to run around, like you have to go another way and then solve it.
Sir, can you please explain second method again?
Okay, so okay, the question is, we have this 4 red balls, 3 green balls, and 2 yellow balls in a something in a jar, and I want to select 3 balls. I have to select 3 balls, but at least this one should be red. Uh, One should be red. So this is my question. This is the task I want to achieve. Okay, and to do that, I have written this first ways. I wrote all the ways how to uh, which way it is going to possible. But that is I have to write all the cases, right? So another way is I can write all the total ways to select something. Right? Total ways to select 3 balls, and out of total, um, there is one way that this one at least one red ball is there. Plus, what is complement of this? What is opposite of this? At least one ball, and not this case, not at least one ball. So that is 0 ball, right? Not at least one ball, 0 balls. So there is no balls in the selections that has red color. So that I have to find, and I have to so this is the one I have to find. So I can bring it other way, right? So this is way. So if I want to find the R, I can write a total minus the R complement, right? and total I know that NC3 way I can choose all of them, and another way is sorry, and complement is 5C3. So I'll subtract that from 84, and that way I'll have 84 minus 10, and that's
Got it, sir. Thank you.
So the 5C are outcome
5C.
5C3.
Why is it there?
Yes. How
Okay.
it is?
Okay. See. Okay. R complement. What is R complement? No red balls, right? In selected 3 balls. So in selected 3 balls. So I need to select 3 balls only. That is the condition. But there should be no red balls, right? So I have 4 red. Okay, 4 red, 3 I guess green, and 2 yellow. Okay. So this 4 I can't select. So that I excluded. So that's why this 5 total came out. And out of 5, I need to select 3 on. So that's why I'm choosing 3 on.
Okay. Thank you.
May I ask you a doubt?
Yeah.
Since in week 5 and tutorial 1, they have already
Okay.
explained in the course, but somehow I'm not able to understand that. So if we have time, or if you can,
Sure.
yeah, thank you.
This is week
Uh,
6, right?
Is this
Yeah,
week
no, that's okay. But because all of the things are,
mixed up? Yeah.
mixed up. Yeah, that's okay.
No,
We'll take it.
this is week 6, right? This currently
Yeah,
you're teaching
yeah,
this.
this is week 6. Yes, combination.
Okay. Thank you.
Combination and application of. So when you do application of combination, that is, you will come across permutation as well. So there's no escape.
Okay.
Okay? Yeah. Okay. Yeah, so okay. Now let's do question. So, how many ways? So the letter of word leading and bearing such a way that the vowels come together. Yeah. Okay. Any suggestion from yours on how to solve this? So vowels is A I O A E I O U. A E I O U is vowels in English alphabet. And I want to arrange this one, right? So this is the word now I have. So that vowels come together. So how to do that?
We have to group vowels together and add it to the remaining letters.
Okay. Yeah. So okay. So how many? What consonants are there? Okay. So I'll write consonants and vowels, right? So in leading, L is consonant, E is vowel, A is vowel, D is consonant, I is vowel, N is consonant, and G is also consonant. Okay. Now they are saying club them together. Okay. So that's what they are saying, that uh, they always come together. So I want to keep them together. So arrangement in this is okay. So let's say E A I come up, or E I A came up, or A E I, or anything else, right? So this all is okay. This all things is okay, but they should come together. There is no uh, nothing should come in between them. Okay. So if I want to do that, then I know that I can arrange this four in uh, four, and then let's say this entity itself. So what I'll do is I'll
Sir,
write
4
LD
factorial and 3 factorial का तो सर निकालना.
in G, and then I have one group. Okay, one group EAI. This is also one group. So I have total 5 elements now. Okay, elements, and this is a group or something, club. Okay, so to do this, we have like 5 factorial ways to arrange this 1, 2, 3, 4, and this whole thing, and multiply it. This 3 also can arrange in itself. So that is like 3 factorial ways they can arrange itself. And there is nothing repeating here. So I don't need to do anything division or anything. This is It's a question of arrangement. So just to be clear that nothing is repeating. Otherwise, I would have had to divide it. Okay. And this is going to be 120 into 6. Okay, so that is 720. So this is 120. And next, another question is, so I have this question which is very similar to what we did now. So can you solve this? Here the
Yes, yes,
marbles are
sir.
there, we took balls. Okay. In how many ways? 3 marbles can be drawn so that at least one black is there. Can you can you solve and give the answer?
Yes, sir. Please give us time.
Yeah, sure. So we'll say 44 is there. We'll 47. 3 minutes.
Okay, okay.
Sir, in the previous question, you said 5 elements. I didn't understand that part.
So you want to try this question?
No, no, in the previous question, I
Yeah,
had
yeah. I
solved
mean,
it.
if you're trying this question, then do it. Then after 67, 467, will sorry, 647. I'll do that. I'll explain.
Okay, okay, okay.
Okay. So one is we'll solve it. Okay. Not worry. So one answer 64. Okay. Anything else?
I also got 64.
Okay. Two are there. So 64. Okay.
64, sir.
Okay. So we'll wait 1 minute. Then I'll solve it. Okay. So 64 is the popular answer.
24.
Okay. 24. Another. Okay. I think I can do it. Okay. So I'll solve. Okay. Okay. Keep here. So I have two white, um, three black, and four red. Okay. And they're saying find how many ways 3 marbles we have to draw. Uh, three out of these 3 marbles. Such that at least one black should be there. So they're saying three, draw three, one should be black. Okay. Now how to do that? So I'll go first like with the complement one. Okay. If you don't get it, then I'll do case by case also. But I think complement way is easier. So total way is select one. So select at least one black plus select no blacks. That is the opposite of that. Select no black marbles. So you get it right. So let's say three cases are there. Let's say one black got selected out of three. Yeah, three blacks are there. So and both two blacks were selected. So I'm just selecting it, okay? Or three blacks were selected. So this all three cases are there. So opposite of that is no blacks got selected. So none, right? So nothing. So that is the opposite of it. So total ways to select three out of this is 5 plus 4 9. So that is 9 C3. And I want to do this. So this is the one I want to find out. And no blacks, right? So I'll exclude this and I have 6 remaining. So from that I'll select three balls, three marbles. Okay. So 6 say 3 and to find this question mark, I need to do 9 say 3 minus 6 C 3. That is going to be 9 factorial divided by 6 factorial into 3 factorial minus 6 factorial into 2 3 factorial. This is if I do, then I'll have 9 into 8 into 7 and 6 factorial got divided, right? This is 3 into 2. So this is 3 into 2 and 3, 4. So 3 into 4 into 7, 84. This is going to be 84. And other side, I have this. So remaining is 6 into 4 into 3. And 3 factorial is 6. Right? So 3 into 2. So this is 12. Um, AM. So that is 2 into 7. Okay.
So
And
you
this is
missed
got
5.
I did. Yeah,
Sir,
I
you
did.
did something wrong. 6 into 5
So
into
five,
4.
five.
Yeah, 6 into 5 into 4 into 3 factorial was there. Then this was removed and right. So this is 5 into 4, which is
That will
20,
be 40.
64. 5 into 4 is 20. So 64 is the right answer. This is not. Okay. So okay, in previous question, do it again. So I have consonant and I have vowels, right? Now they are saying that group them. They should always come together, right? So and what I'm doing is I'm grouping them. Now, if there is a group, then I know for sure that they'll always come together, right? So let's say this they came like this and like this, or they could come like again this group, this group, and then ng or any way, any other ways. There are all the ways that is possible to arrange them. So now this group is always coming together. That I'm sure of because I've clubbed them. I'm not uh, moving them around, right? Uh, in between, I'm not putting anything. So since I have grouped them or I bound them, there are like five uh, entities, five elements left, right? So now I have five elements only. And five elements can be arranged in five factorial ways. Okay. But in one out of this five, this contains three elements. And then those three also can arrange in itself, right? Anyway, like EAI is there, or EIA can come up, or IEA can come up, something. So this all arrangement are possible in this also, vowels. So that's why this 3 factorial is there. Okay, from that. And 5 factorial is 120, and 6 factorial is, sorry, 3 factorial is 6. This is 720. Okay. Okay, now if there is any doubt in any factor assignment, we'll take it. Okay. So I think concept wise,
Sir, can you please explain that at most condition?
at most. Okay. So okay, maybe at most. So let's say same thing. So earlier example was right. I had this. I had this. Uh, and the question was how to select at least previously at least one or something. Now let's say I'm selecting three. I'm selecting three. Selecting three. But I'm saying at most. At most. Uh, select the at most two reds. Two reds should be there. Or at most two reds are possible. Okay. Uh, Not should be, but it's like two reds can be there. Can be there or something. It's okay. So in this case, what I'm restricting the other way. So let's say if I select three balls, so say one, two, and three. Um, so now possibilities either I have one red ball or two red balls. Okay. I can't have three one. I can't have this one. Okay. Uh, yeah. At most two, something like that.
You can
So
have three also, sir. Three, no red also can have, correct? At most.
yeah, at most two.
Means
So at
no
most,
red also okay.
yeah, no red is okay. No red is okay. Yes. So no red is okay. Yes. But a red should either come one or two, and of course no reds are also possible. Okay. So so in this cases, I if I go and find this, it is going to be difficult for me. So what I'll do is again I'll do total base is equal to at most two reds plus uh, plus all reds, right? All reds, right? Like if I have all the reds, then that is the opposite of this, right? At most two. Yes. So total ways to select is 93 since we have nine balls, and at most two. I want to find out that, and all of them are red. So how many ways are that? So I have four, and I want to select three out of that. So all red is 4C3. So that way I can do 9C3 minus 4C3. Okay. So this was 84 from previous year. Okay. And this I need to find. This is going to be 4. 4 factorial by 3 factorial into 1 factorial. If you do, this is going to become 4. Okay, so 84 minus 4 is 8. So there are 80 ways to do. This is at most case. Same thing. Like in at least we were on the on this side. Let's say this side, and in at most we have to go till let's say 0, 1 ball or 2 balls, but I can't go more than that. So 0 balls case, yeah. So in this, if I go case by case, then I have to like 0 red balls, 1 red or 2 red, right? So this three cases are there. You can add them also. So let's say zero red balls. That means I have five. Out of that, I have to select three, right? Plus now one red ball is out of four red balls are there, right? So I have to select one out of that, and rest of two will come from this five elements. So that's 5C2 plus two red balls now. So 4C2 into 5C1. Right? So in this case, you can write maybe 4C0 or something, but uh, that is going to be 1. Okay? So 5C3 is 6. This is going to be 6. This is going to be 4 into 10 plus this is going to be 4 into the 12 by 2, 6. This is going to be 5. So it is this is 40 plus 30.
5C3 is 10, no?
5C3.
5 is there.
Yeah, 10. Sorry. 10 is there. 5C2, 5C3 is equal. Correct. 40 plus this is 30 plus 10. 70 and 80. And that's what my answer was. Okay. 8. So either you go case by case or you do this way. Both are same, but in this case there is a chance of missing something. Okay? So there is a possibility that you might miss something. But in this case, it's a lot easier that you do total minus all of it. Yeah. Okay. One thing I think I need to cover is when there is a circular arrangement. Okay, so I have circular arrangement. So how I see is, let's say I have A, B, and C. I always go like anything, or clockwise, anti-clockwise. Your choice. I go clockwise. Okay, so I write this like this. So if I write like this, and there's another case which is like A, B, and C. If you see this both same, there's nothing different than it. It just you changed it. Okay, you just rotate it or something. So this case are same thing. Okay? And another could be, let's say, uh, I write A here, B here, and C here. So all three of them are same one. Nothing changes. Just you rotated it like this. Okay, it's just rotation happened, but arrangement wise, it's the same thing. Okay. Uh, so okay. So what is the difference? So in this case, let's say if I write, if it was linear pattern, right? Let's say this part, first one. If I write A B C, and in this case, if I start from top, this is C A B, and this case it is B C A, right? So this all arrangement are different and in linear pattern. But in case of circular arrangement, uh, they are same, right? They all represent same thing. Uh, so uh, how to do circular? If you have circular arrangement, any number. So let's say I have n objects. Okay, 1, 2, then 3 and 4. So let's say, so I have n elements. N elements are there, and they are in a circular pattern. Then I can arrange them in n minus 1 factorial. Okay. So if I have, let's say, 4, then that is going to be 4 minus 1 factorial. This is 3 factorial, which is 3 into 2 into 1, 6. Okay. So 6 ways I can arrange this one. Okay. Earlier it was 24. If I had just n elements, arrange them in linear order, then it was going to be 4 factorial, right? So that is 24. But in this case, it is n minus 1 factorial. So most of the cases are similar only. You can maybe draw it also. So like so another case of this is, which is same, right? Same as this. So if one starts from here, then it looks same, right? To so you can go either this way or this way, your choice. But I always, go clockwise. Okay? Yeah, and another thing could happen in this circular arrangement is, so here
And
we
people
had
are
a
going.
different objects, right? But maybe possible that you have, let's say, same object. Let's say red or blue or something, right? So let's say uh, object is there red, then let's say blue here, and let's say yellow here. So if you go this way or that way, this looks similar in both the cases. So now the flipped of it, there's a B1, this B2. Let's say they both are not different. It just I'm numbering them. Then the other variation of that is there's a B2 come here and B1 come here, and it's red and white, right? So these two are also now same. So if you have you know clockwise and anti-clockwise similar arrangement, a similar thing, then in that cases you have like n minus 1 factorial divide by 2 on that. uh, uh, this is how formula happens now. So if the question is like this, then you have to divide it by 2. Okay. I think I covered all the concept wise. You can, yeah, if you have any doubt in any practice assignment,
Sir, some of the
correct.
assignments, there is some terms simultaneous and replacement that nowhere covered in the videos. Can you please explain what is the
Okay, so
simultaneous?
sir, sorry, replacement or what was the replacement?
Replacement or not, and simultaneous or not. Some questions are
Okay,
there.
so the replacement is okay. You, let's say if you can replace, replacement is possible. That means repetition, right? That is repetition. Repetition is possible. Okay, so now okay, another term came up, but I'll explain. So let's say question is uh, 1, 2, 3, 4. Okay, no, not eight. It's 8, 9, 10, and 11. This four numbers are there. You have to form a three-digit number out of this. Okay, three-digit number. So like this, uh, out of this four, out of this four only, and repetition is allowed. Okay, repetition is allowed. Then how many ways can you create this number, three-digit number? So this repetition is like replacement is yes. So replacement means I'm not excluding now. So let's say I choose anything. Let's say 8 is chosen here as a number. Okay, as a number. Then in next one, 8 can also appear again, right? So 8 can come again, and it can also come again also. So this scenario is called like replacement is possible. Repetition is there. Okay, replacement or repetition. So um, so if replacement is there, then the number of three digits, like three-digit numbers, can be formed out of this is. So in this case, all the four are possible, right? 8, 9, 10, 11, anything can come up. Then in this also, all the four can come up, and in this also all the four can up. So it's a 4 power 3. And let's say what if replacement is false? Like replacement is false. Like you can't replace now. Okay? Once you chosen that's all. So in that cases, what will happen is, so I have this 8 came here, then I can't choose 8 here. So I can either choose 9, 10, or 11, or something. And if the 9 came here, then I can't choose 9 also. So 8 and 9 are not possible now. I have to choose 10 or something. So okay, I think I choose something which is two-digit. I mean, I have to use something 7 or 6. Okay. So okay. So 10, 11 is not a digit. That's it. Uh, okay. So if you have to form three-digit number out of this, then you have four options available. Like this. If replacement is true, then all the four can come up. But if replacement is false, then all four will not be there after once one is selected, right? So that's a three-digit are there. So here anything can come out of four. So that is four. Here now three are there. So three get two, right? So this is actually four factor, correct? 4 into 3 into 2 into 1. one is nothing. So this 4 24.
So replacement is nothing but repetitions allowed.
Yeah,
Correct?
repetition. Yes.
Hello,
Okay.
sir. Hello.
Yeah.
And what
Hello.
is simultaneous, sir?
Can I ask it out?
Uh, sure. I'll explain what is simultaneous, and we can.
Okay.
You can explain
No,
order also. Order matters. Order does not matter.
regarding to the lecture 3, week 5, lecture 3, I have a doubt. Can I ask?
Yeah. Okay. I'll explain simultaneous, and you can do it.
Okay. I understand.
So okay. Um, so when two events can happen together, so simultaneous is together, right? Together, something happening is a simultaneous event. So let's say you know um, what could be that? So let's say year is there, okay, or a month is there, okay. So what is chance that a day is Monday, and date is also one, okay, something. So this is something a simultaneous condition, a simultaneous case. I have no question in mind, but when something is happening together, right, together, that is simultaneous. So
For example, I have some gifts and a gift wrappers. That is the question actually. How can how many ways we can match this gift wrappers and gifts? Different numbers of gifts are there. Different numbers of gift wrappers are there. Okay, I want to pack with gift wrapper, each gift. So that comes under simultaneous or not simultaneous?
It is a simultaneous because we have to select wrapper for each gift at the same time.
Okay. Okay, sir. Okay, sir. Clear. So can you explain one example for not simultaneous?
not simultaneous. That's all. So this wherever or cases are there, right? This or that. So that is not simultaneous. Like one thing is happening, but not the other one, right? So let's say what we did here.
Yours
Yeah.
about
Let's say this one, right? Either you do this or this or that. So this all are not simultaneous. I mean,
Even
this
when the events come one after the other, that is also
yeah,
non-simultaneous, right?
yes, that is also not simultaneous.
Okay, sir. Okay. Thank you.
Yeah. Yeah. Okay. So what doubt you have with practice or anything?
So week 6 got over.
Yeah.
So
Week 5 says
can we
more.
do that week 5 and tutorial 1?
Yes, sir. Can I ask?
Tutorial 1.
Tutorial 1. That
Where is that?
4 women and 6 men, the pair.
Week 5 activity
Tutorial 1.
question or
Tutorial 1.
tutorial? This video.
Yeah. It appeared so simple.
Yeah. I'll look into it. Okay, this is the question, right?
Yeah.
Hello, sir.
Yeah. Yes.
Sir. Hello.
Yeah. Hello.
Yes, sir. Sir, I have a doubt.
Yeah. Okay.
Sir, I have a doubt in 5.2. Grade 5.2 practice assignment. No, sir, it's a activity question. Activity question 2.
Activity question 2.
Activity 2, question number sir 4.
Okay. We will take it. Okay. So let me do this. I'll do this. Then we'll go to activities. So in building six, again, building six men are there. So yes, say six others. So and four women are saying, there are exactly three married couples. In how many ways can you guess who the couples are? Okay, so
Actually, the question itself is a bit confusing to me. I don't really understand what they are asking there, because the answer that came, it's about 480. That is how they have explained it. But I made it as a very, I got a very simple solution. I just multiplied 6 multiplied by 4, something like that. I thought only 24 pairs are possible. You have 6 men and 4 women, so not more than 24 pairs are possible. Then how do we get four? See, I may be completely wrong. I'm sure I'm wrong, but I'm not understanding that.
How many ways you will be able to choose couples? That's the question.
Yeah. So the maximum number of couples could be only 24, isn't it?
No, but
So
then
because
if suppose 6 men are there and 3 women is selected, and you take every man is connected with each other, so they would have a one pair, right? Two pair,
yeah,
three pair. So they have to do the combinations like that. So then you will able to add. So each man there will be 3 women. You can connect like that. Then I will be able to. You will be able to do it.
that is what the solution is actually. But when you look at the question, the simple thing that we come to understand here is, oh, there are 6 men, just like the shirt and pant combination, which we had. There are 4 shirts and let's say 5 pants. That's a pair, isn't it? So I simply multiplied 6 multiplied by 4 and 24. So the maximum number of pairs could be 24. But actually, I know I'm wrong, but I'm not able to understand that concept.
Mhm. Okay, give me a minute.
It's given that there are three married couples, so I think we have to do something with that. Except we don't need 24 pairs. We only need three.
Yeah, we need three. There are exactly three married couples, and how many ways can you guess? You can guess who the couples are. So, and what are total options are there? That's what the question is. In how many ways you can guess? So, basically, total options. How many options can
So
happen?
permutation possible with 6 men and 3 women, so they can connect. So there are 4 women staying, 3 women
Mhm.
couples, and there are
Mhm.
exactly 3 married couples. So if they are married, then it has to be the number of ways you can find. So they will be married.
Mhm.
It's all about guesses, right?
Yes. So,
Number of guesses. If we compare 3 women, 1, 2, 3 by 6 men, the number of cases will be 3 women.
in building six men.
My approach was like this, very very simple approach. I thought, okay,
Mhm.
there are 6 men and 4 women, so the
Mhm.
maximum number of pairs possible would be 6 multiplied by 4, which is 24. Now,
Mhm.
in how many ways can you guess who the couples are? So we have to guess, we have to find out how many different ways
No,
we
no,
can
no. But
guess
then
who
you missed out that every woman man can connect with other women. No, you
yeah,
only
Yeah, and
you only
exactly.
multiplied once with every. So number
uh,
multiple permutations would possible would be more.
no, isn't this something similar to those 4 shirts and
No, 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 no,
five,
no, no, not like that.
mm,
Because each man can connect with every woman, right?
yeah,
So
so
similarly,
that's
six men.
4.
So
So
six
that,
men will connect with other women also, right?
okay.
So you have to just start using like that.
okay. See, uh,
Yeah.
okay. Maybe I can try. So let's say there is a man and there's a woman can form a couple, right? Uh, out of six, we can choose any three to be a couple. So to be a man. Okay. So out of six, and then let's say if I multiply three, sorry, four out of this,
That will be
three,
4 multiplied by 3 multiplied by 2.
4C3, and that is like all the humans are there, and I have to multiply it, right? And because out of six, I'm choosing three, and out of all the humans, I'm choosing three. And if I do this, 6C3 is going to be
This is 4.
six,
I mean, this is.
and this is four itself.
Yeah.
And if I do
No,
this,
that will be 5, I think. Isn't it?
which one is five?
I mean, 63 will be what? It will be.
Yeah, 6 into 5 into 4. So 6 into 5 into 4. And if I do this, so 5 into 4, 20 into
20.
4.
So that will be 20. Yeah.
Yeah. So this is okay, coming out to be 81. Okay.
No, no. 4C3. Oh, I see.
Yeah, 4C3 is 4. This is
I think it should be 4P3.
so you're saying we can arrange them. Okay. Select and arrange.
So if it is 4P3, what do we have?
Hello. Am I audible?
Yeah.
Yeah. Okay. So in this case, actually, so you can simply do, see, you have six men, right? So let's say you have M1, M2, M3, M4, M5, M6. All right. Four
Okay.
women. Okay. So four women means, let's say I'm just assuming W1, W2, W3, W4. Okay. So we need couples, right? We have to find the number of ways who are the couples, correct? So what we can do, okay. So basically, if you see, and we know there are exactly three married couple. All right. So to find this, how we can proceed? So first of all, can I do? Okay, let's do this in two different approach. Okay, let's say approach one. Approach one. Let's say I'm interested to know. See, there are total four women, but we don't know to know the exactly three married couples. We know who are they three. Correct. So can I? In how many ways I can choose three women out of four?
4C3.
4C3. All right. So this
Yeah.
will be four, right? So what are these four ways? So these four ways are nothing but basically it can be W1, W2, W3. Yes or no? It may
Yeah.
be W1 and sorry, W2. Let's say like this. W1, W2, W4,
So
right?
that's a permutation there.
W2, W3, W4. No, I'm talking about combination. I'm talking about these
Oh,
four possible pairs. Okay.
oh, okay.
And the
Okay. Okay.
others one is
All right.
what
Yeah,
is
understood.
left?
Understood. Yeah.
One case I think I left, right?
Three,
W1,
one,
W,
four, one, two. And you
yeah,
need,
W1, W3, W4, correct? So these
yeah,
are the four possible pairs for women. Yes or no? Like,
correct.
correct? These are the four way in which three women can get married, something like that. Okay. Now,
Okay.
we have to think. So for this first women, what is the possible ways?
You have 6 men.
Six men, right?
Yeah.
Into. For this women,
5,
for this women,
4.
that's all.
That's all. Yeah.
For this case, similarly,
Same thing. 6, 5, 4.
654,
Yeah.
654,
Yes.
654. All
And
right.
we are
So
running
we
out.
have total four cases, right? So
Yeah.
4
Yeah.
into 6 into 5 into 4. So this will give you,
Yeah.
I think, 6, 5, 30, 30 into 16. So 480 ways we are getting, right? Let's do
Correct.
in different, I mean, with approach second. Okay.
Okay.
So here, what we can do to know, to get this three married couple. there should be some three men who will get married, something like that, right? So what is the possible way I can find men out of six?
How many married couples?
63.
Yeah, I it can be done in six C3 ways, right?
Now this is you are taking men into consideration first,
Correct,
and
correct,
then
correct,
matching
correct,
them with the women.
correct, correct. All right, let's
Yeah,
see whether we are getting the same answer or not. Okay,
we
so this is the
we'll get the same answer. Okay, please
will
proceed.
not
Yeah,
get the same answer. Okay,
yeah,
okay, let's see. So this is 6C3. So 6C3 is nothing but 20.
yeah.
Okay, so these
Correct.
20 are what? These 20 are nothing but you will get something M1, M2,
Yes,
M3.
yes.
It will be
Units.
M1, M2, M4,
Yeah,
M1, M2, M5, and so on, so forth, right?
like
So
20.
you'll get some 20 pairs. Now, all
Yeah,
right. Now,
yeah.
for the first main, what is the number of options? In
Four,
how many ways? Four, because there
four.
are total four women. For
Yes.
this main,
Three,
for this,
two.
similarly, here, 4 into 3 into 2, up
Yeah.
to
So that becomes
20 times.
20 times.
So it will be 20 into 4 into 3 into 2, which is
Yeah.
nothing but 3 to
So
6, 4,
yeah,
24.
80,
That is 480.
240, 480. Yes.
All right.
Yeah,
Now it's
this
clear,
I
right?
can understand. This I can understand. I can understand the
Hmm.
solution here. But
Hmm.
my problem is,
Hmm.
why isn't the other way of thinking not arriving at this solution? Like you
No.
have six men and four women, so the
Uh-huh.
maximum number of pairs possible would be only 24 pairs.
No, no,
I mean,
no, no. It's not that.
that
So
would,
what you are doing, basically you are doing simply doing like there are two chairs and you are just filling that positions.
yeah.
Okay. It's
And out
not
of
like
those
that.
24 pairs,
Hmm.
only three pairs are married actually. See, the maximum possible pairs are 24. Out of those
Okay.
24, only three pairs are genuine couples. So the remaining 21 are not. So in how many ways can you guess who the couples are? Like, I mean, that approach, it's blocking all my clarity. So
Okay, okay. It's not like that. See, it's that in 6 into 4, right? What you are doing is just you are basically counting one man and one woman, something like that. All right.
yeah.
So, as per your thought, right?
See
I
this
think.
approach. See, once we
Hmm.
know the answer, we get this. I mean, we understand this approach. But
Yeah,
when we
yeah, yeah.
don't know the answer, the first
Hmm.
thing that comes into the mind is, okay, there are 24 pairs, and only three are genuine. So, what
Hmm.
are the possible ways to identify those three out of 24? So, will it? I mean, can we?
No,
Do we
no.
have a solution with
Sir,
that?
can I say something?
Yeah,
Yeah.
please go ahead.
If
Yeah.
you are doing 6 into 4, that means you are choosing two men and two women also. It is compulsory that there should be one man and one woman. Then
Yeah.
only they will make a couple. If you are
Yeah.
doing
That's right.
6 into 4, that means you are choosing two men also and you are choosing two women also. So that's not possible.
Does that come here? I mean, is that happening?
Yes,
To
if you are doing
so
6
the
into 4,
no, let's say men M1, W1, M1, W2, M1, W3, M1, W4, and then M2, W1, M2, W2, M2,
Okay, okay.
W3.
So, what
So
you
that
are
comes,
doing
that
basically?
is 24, isn't it?
No, no. So
There we don't even.
no, no. If
Yeah.
you are doing M1, let's say M1 W1, right? Then
Yes.
just think how many possible pairs. So M1 W1,
24.
then it will be M1 W2, right?
So
But you
that will
don't
24.
that will 24, right?
Yeah.
One second, one second.
So
So mhm.
so can we, and you, out of this 24, only three are genuine couple. So, I mean, do we have something like 24 and 3? I mean, 24C3 or 24P3? I mean, is there any kind of solution like that?
No, no. Then I think we need to cross check with that. We will come up with something. So don't worry about it. But see here, what you are doing basically, you are just simply thinking about two things, right? Like you are simply suppose you have two positions, you are just filling that one. But I don't
That's right.
think it's
Not the right way.
not a right way
But that I
because
understand. That I
hmm.
realize only when I know the solution.
Okay, all right, all right. So okay, so whatever you are saying, we'll think and come up with something. Okay, we'll see what's the wrong in this approach. All right, okay,
Okay, yeah.
yeah, yeah,
I think I get it.
yeah. Go ahead.
You
Yeah.
said something like total of 24 pairs, right?
Yeah.
Yeah. So
Can you take my
so
doubt?
what I was saying is, so from those 24 pairs, we have to actually select 3 pairs.
Hello,
So what
sir.
we can do, like we selected the first one, second and third. That becomes one kind of way. But you can also select like the fourth pair, the fifth pair, the sixth pair, and something like that. We can create more pairs.
Sir, may I say something?
Yeah, go ahead. Go ahead. Yeah, go ahead.
Sir, I have a doubt in lecture 5.3.
Sir,
Activity question 1 and 4. So can you solve for me? Can you take a look?
hello सर कब से बोल रहे हैं हेलो सर
Yeah, hello.
हेलो सर
Yeah. Yeah, go ahead. Yes.
Activity
My
question
audible.
5.3, sir.
Activity 5.1.
सर activity 5.2
5.3.
question number 4
Activity
5.2.
5.3, question number 1 and 4. Can you take a look?
sir activity 5.2 question number 4 please sir
Yeah, 5 point. Wait, where
question
is
number
5.2?
4
5.3,
5.2
sir.
activity
There is no 5.3. There is only 5.2. Okay, this is the last.
5.4 तक है
5 point.
तक है yeah 5.4 तक है its last is permutation combination permutation object not distinct and circular permutation
Yeah.
I think there is a glitch, sir.
Okay, okay. Okay. 5.3. Yeah, okay, okay, sir. Yeah, sir. Okay, so 5.3, question number.
1 and 3.
5.2 sir sir
Yeah,
5.2
we'll take both. Okay, we'll take 5.3. We're 5.3. Let's just say 5.3. 5.3. Question number 1.
Yes, sir. Yes, sir. Question number 1 and question number 4.
Okay. Okay, so question number 1. And how many ways a test paper of 6 questions we attempted, each question being a true or a false?
Yes, sir.
Okay, let's see. So 6 question can be written, and how many ways test paper can be attempted? So let's say he wrote first is true, second true, all true, right? This one possible way. Then
Yes.
uh, T and F or something like this, right? So
Yeah.
for all the cases, let's say for first uh, option we have two options available, right? True or false, correct?
Okay. Sir, hello. Can I say something?
Yeah.
Sir, I tried. Uh, if a question is there, then there is two possibilities only. Eh, The question will be true or false.
Yes.
Then a question have only two options.
Yes. 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 Two option. Yes.
Then why I am getting wrong answer, sir?
But there are 6 questions, right? And
Yeah.
see, they are saying in which way attempted. So either let's say you write first anything true or false. Second, you can write true or false. Then another you can write right. So all the things. So for each case there are like two things, right? So what you have to do? 2 into 2 into 2 into, right? So there is 2 power 6.
But the answer is wrong, sir.
What is the answer?
You consider not
36.
attempted also option. So 3 options.
Yeah. Option is 36. Yeah. How many ways can you test?
He
Sir,
cannot attempt also. He can leave the question.
the option is 729, sir. Answer
3
is
raised to power 6.
729.
3 raised to power 6.
729.
Yes, sir.
And how many ways it is? Yeah. Okay. So we attempted. Each question being our true plus false type.
So there is one more possible way. We can leave the question.
You can leave as well. Okay. So then it will become, there will be
3 power
power
679.
3 power 6 then. If I leave a question.
Yes, sir.
But
That's the
there
only
is,
possible way.
but sir,
Option number 3
there
may
is
be
not,
सकते हैं जी.
sir. How can I consider for leap, sir? There is written that each question being a true or false type. Then how can we
It
consider
is
that?
asked that how many ways you can attempt that. It's not necessary that you should answer true or false. You cannot answer. That is also an option.
Okay. Yeah,
Okay.
so okay, if this is a little ambiguous, then we can replace this thing, that, or maybe we can add that uh, uh, so each question has this option, but you can attempt in you cannot attempt also. That option is also there. Just for question be attempted if
If
each
there was a
question is
condition
4.
that each question should be answered, then it would be 2 to the power 6.
Yeah, yeah. So if there is another option is there, like not attempting, then that is 3 power 6. So yeah, okay. So it's just a question, okay? So don't worry. Like the cases are either way, right? So if necessary to give the answer, then 2 power 6. If not necessary to give, then there is like another option can come up, let not attempted. So that is 3 power 6. Okay.
Okay.
You don't even get.
Okay, sir.
Okay, but in
Then
this,
I think it will got the right answer.
yeah. Okay. Another
Okay.
question.
Question number 4, sir.
Okay. In how many ways can 5 distinct books be arranged into bookshelves? Okay. So okay, this is okay. I think so. There is one bookshelf. I can arrange all 5 in this. Okay, or I can arrange all 5 in this, or another is like 4 I can here and 1 here, right? So this all uh, possibilities are there.
Yes, sir.
So to arrange 5 books um, in this is so there are like 4 cases or something. I think. Say 5 here, 0 here, 4 here, 1 here, 3, 2, 2, 3, 1, 4, 0, 5. Okay, so 6 cases are there, I guess. If I am not wrong. Okay, so let's say this 3 cases, and then I can multiply it by 2. Okay, so what I'm saying is 5, 0,
Yeah.
4, 4, 10,
4
1,
1.
3, 2. Okay, then I can multiply it by 2. So that is uh, this 4, what's that? 2 and 3, 1, 0. Okay, so this if I know this, then I just need to multiply it by 2 or something. So I want to arrange 5 books in one shelf, right? So that is 5 factorials, right? So 120. And I will not arrange anything there. So 0 factorial is 1, right? Plus I'll arrange 4 here, 4 books here. So that is 4 factorial, right? So 24. And there I'll arrange 1 book. So that is 1. Plus I'll arrange 3 books here. So that is 3 factorial. And I'll arrange 2 books there. So that is like 2 factorial there. Right. And then I'll have multiply whole thing by 2 because of this case.
Hello, sir. Can you repeat this question?
Yeah. So there are like 5 distinct books. We arrange in 2 bookshelves. So I have 2 bookshelves, right? So basically the thing is I need to choose the book. Okay. 5, the let's say 1, right? One book, or all the books I selected here. Then I am arranging them, right? So select and arrange. So I'm selecting some books. So either I can select 5 book, 4 book, 3 book, 2 book, 1 book, or 0 book in bookshelf 1, right? Then in opposite case also it's there, correct? And then I have to arrange them. So I'm not using combination C1 and something. I can directly do it, but that way is also same thing. So let's say 5C1 and then arrange the one book, which is 1 factorial, right? So that is 5P1. You can do that way also. So you can do P way also. So if you know this is 5P5. This is 5P4. Okay, so you can do that way also. Same.
Okay, sir. Okay, I understand, sir.
There is
Yeah.
5P3 and
Thanks a lot,
5P2,
sir.
तो उसके बाद सर
Hmm.
5 फैक्टोरियल अपॉन 5 माइनस 4 फैक्टोरियल के निकालना पड़ेगा ना.
Uh-huh. And this way also. So this I'm saying that 5 books are there and they are distinct. So I don't need to worry about. So I can directly just arrange them. Right. So I selected already 5 and I'm arranging them. I selected 4 and I'm arranging them. Selected 3 and arranging them. And the opposite way, there are 2 other which I have to arrange. So 2 factor ways I can arrange it. 2 ways basically. So this is 120 plus 24 plus 3 to the 6, 6 into 12. Okay. And multiply by 2. So this is 2 plus 4, 6, 1, 2, 3, 3 plus 2, 5, 1, and multiply by 2. So this is going to
It's
be
30312.
1. Yeah, well, so 150 is 300 and 6 is 12, right? So that many ways I think.
So also question number 3 हम बनाए थे इस क्वेश्चन को. दिक्कत ये हुआ मतलब सर गलत पहले ही बोल
Yeah.
सर इस क्वेश्चन को बनाया था क्वेश्चन नंबर 3 को. वहां से मेरे कुछ और ही आ रहा है. मैंने इसको परम्यूटेशन लगाने की कोशिश की. परम्यूटेशन तो मैम बताई थी, कॉम्बिनेशन लगा नहीं सकते क्वेश्चन
और
नंबर 3.
इसमें
तो सर
क्वेश्चन
क्या
नंबर
हुआ कि मैंने 5 फैक्टोरियल अपॉन जिससे लिखा हुआ था वहां पे 5 फिंगर है, तो ये तो 5 फैक्टोरियल आ रहा है. दूसरा तो 120 आ रहा है, बट हमको लगा कि गलत है. उसकी बात
पहले तो यहाँ फिर इस क्वेश्चन का आंसर गलत आया. Give me a minute. But so this I'm saying that 5, then I choose 1. Then I choose that. 5 here, 0 there. 2 there. Distinct books in 2 cells. So this is 120. So this is definitely n. And I'm adding all the pieces. So plus 24 into 1 plus 6. I think what I'm missing, the ways to select the books.
So 5P4 will be 120 also.
What I'm missing is I'm saying the 4 are there, but which 4? I think I need to define that. So I have to do 5P5 and 5P0. This is when 5P4. This is 5P1. 5P3. This is 5P2. Five P1, 5P4. This is 5P0 into 5P5. Right? So if so this two are same, I think this two are same and this two are same. So I can do this and so if this is 5P5, that's just 5 factorial divided by 0, and 5P0 is 5 factorial to divided by 5, so that is 1. This 5P4 is 5 factorial divided by 5 minus 4, which is this 5. And this could be 5 factorial 5 minus 1. So that is 4 factorial. Eight. 5 minus 4 factorial. Here 5 minus 1 factorial. In this case, 5 factorial divided by 5 minus 3 factorial. That is 5 minus 2 factorial. So this is 5. If I do this, 5 minus 4 factorial is 5 minus 4 is 1. So yes, so this is going to be 1 factorial. And if I do this, this is 5 minus 1 4 factorial. So that is going to be 120 into 5, right? So 5 into 4 factorial. So can remove this, and 5 factorial itself is 20 into 5. This case, 5 factorial is
Sir,
120. So
sorry
yeah,
for disturbing you, sir. Can you explain question number 3? ये क्वेश्चन पहले से ही गलत है, हम भी बहुत ट्राई किए थे, सही बता.
No, sir, this question, I got the answer, sir.
no. This is
So literally
wait,
बहुत
wait,
मसा लगा this question.
wait a minute. So 5 factorial divided by 3 2. So I think answer is 1 into 5. Okay, I need to add them. Not 1 plus
Yes.
5 plus plus.
Hey, sir, in this question, we have two bookshelves, no? So we can put like
Yeah.
5 books in one shelf and 0 in other. And then we can put 4 in one and
Mm-hmm.
1 in
Yeah.
another.
So
That's the
this is 12
simple explain. We can add and we get 720.
to 120 into 2. What would be that?
Sir, I think we should add like we can select 5C3.
Uh-huh.
Sir, it is the right approach. We will get the
Yeah.
answer.
Yes, sir.
Yeah. I think. But it is not 720. Mm. I'm selecting it correctly.
So from each of the case, we will get 120 and total will be 720.
From each of the case, we'll get 720. Okay.
Yes,
So in this case, let's say in this case, okay, 5p4. We got 5 factorial divided by 5 minus 4, which is 1 factorial, which is, so this itself is 120. Then 5p1 is 5, right? 5p1 is 5. So this is 120 into 5, isn't it?
Sir, in one case, like if we take 5P5, then in another cell we do not have any book to arrange.
Yeah. I think what I must is, we have 2 book shelves. Here, if I choose a book, 4, then I don't need to choose again here or do anything. I just need to arrange them or something. I think that's how it goes. Okay. So if I choose any book here, so let's say 5p5,
Yes.
here, then nothing here. Then let's say I choose 4 books here, and arrange them. Then I'll have 1 only. I don't need to choose or anything, right? Then here, if I do 5p3, then again I don't need to do anything.
Sir,
There,
we have two books here left.
just arrange them, I think.
Yes, sir.
Yeah, okay, so this way, this is 2120, this is 2120. 5p3 is 5 into, yeah, and 5p3, 5 divided by 5 minus 3, yeah, into 3. This 20 into 360 into 2 factor is 120. This coming out to be 360, and this double of that, because that will get you 7. So yeah, I think here we don't need to choose. If we choose here, we don't need to choose again here for another bookshelf. Just arranging them will suffice. Whatever books left, right? So left book will just arrange them.
Okay.
Yeah. Okay. Yeah. Okay. Which other question? 5 point activity 2. Yeah.
Sir, I
Which
have a
question?
doubt in 5.4
Okay. Okay. In activity 2, somebody had doubt.
activity question.
Somebody had doubt in activity 2. Okay. In activity 1, somebody has doubt. 5.1. Any question?
5.2.
Your voice is breaking.
Am I audible, sir?
Yeah, you are audible. Go ahead. Which question?
Sir, 5.4, question number 1 and 5.
So in 1 there is no doubt, right? I can go to
No.
5.2, no doubt. 5.3,
Mm,
no doubt. Okay. 5.4.
No. Yeah.
Okay. 5.4.
Activity 1 and
This.
yeah. Question number 1 and 5.
Okay. Find the number element of letters. Okay. This is very easy, right? You just need to count it. Number of rearrangements of the letters. Arrangement. Okay. Yeah. So rearrangement, right? So you are just you're choosing all of them, but you are just arranging them, right? So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So I think 11 are there. But let me put a count of this. So P once, then ROG, there is no P, right? So 1. If I write R is 1, 2, twice. Programming. O is also once. If I write about G, that is 2. So this G here and here. Then A is coming out to be 1. Then I have M, which is also 2. I have I, which is 1. N also 1. So if I sum it out, 1, 2, 3, 4, 6, 7, 9, 10, 11, right? And same 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. So this is going to be 11 factorial divided by this 2 factorial, this 2 factorial, this 2 factorial. So this is the answer. Okay.
Okay, sir.
Yeah, you can maybe calculate.
And sir, question number 5. Also.
This one.
Yeah, sir. Yeah, this one.
This is just a linear algebra, right? So n, okay, let's n plus 1 factorial upon n plus 1 minus 2 factorial is equal to 4 times n factorial upon n minus 1 factorial. Okay. Now what I'll do is this is if I write this is n minus n plus 1 minus 2, so that is n minus 1 factorial, right? So this both can be removed, and n plus 1 factorial is n plus 1 multiplied by n factorial. You can write that way. This is 4 into n factorial. So again, this can go away. So n plus 1 is equal to 4, then n is equal to 3. Okay. You can maybe check also. So to say 4p2 is equal to 4 times 3p1. So 4p2 is 4 factorial divided by 2 factorial, 3 factorial divided by 2 factorial. So this can go away. 4 factorial is 24, and this is also 20. This can. Okay. N is 3. Got it?
Okay, sir. Yes, sir. Sir, I have the one doubt of question is graded assignment.
Yeah.
Graded assignment is question number 5, but I think you told it's but this patent you example.
So 5 graded assignment 5.
Yeah.
Which question?
Question number 5.
Question number 5. Okay. Ram
Yeah.
has an topic that he wishes to place in his main cabinet, which is space only for 2 trophies. Yes, and it is place in his main cabinet, which has 2 spaces only for which is registered to 2 space. If the number of trophies increased by 3,
Yes.
then the number of
Question.
possible ways to arrange the trophies in the main cabinet comes 5 times. This that he wishes to there are 2 spaces available. Yes, and they wish to which has space only for 2. Okay. If the number of trophies is increased by 3, so let's say it increased by 3, then the number of possible ways to arrange the trophies in the main cabinet becomes 5 times number of ways to arrange number of ways, so that is n factorial basically, n trophies. If we can see that it's like np2, because trophy 1 and trophy 2 is like different than like this one, right? So only for 2. If the number of trophies into a 3, now what is increasing by 3? And the number of possible ways to arrange the trophies in the cabinet 5 times.
think the number of ways Ram can place his trophy.
Excuse me.
Will be n into n plus n minus 1.
Excuse me.
Yeah.
Are we solving this graded assignment 5 today? I mean,
No, just looking at it. So I'll
okay, because we have a
you can
deadline today. I don't want
yeah.
we to get into trouble. Okay.
Yeah. So just if there is some
All right,
idea I
no
can
problem.
give,
Yeah.
I have no idea. So
That's okay. Okay, I understood. Okay.
you had doubt in activity 2? Oh, oh, somebody.
Sir,
Okay.
of this graded assignment, I think the question number 11 has wrong options, sir. It doesn't have the correct option.
Question number 11.
Yes, sir.
This one or another one?
Oh, sir, it's a different one for me.
Oh, for you it's a different one. Yeah, it could be possible that for you it's a different. And this there is no option. I think this does have option.
No, sir. So,
I think EMQ one.
Oh, in the EMQ, we have to upload in zip file. Huh?
no, sir, it's for grade assignment 5 only. It's something to form a 3-digit number. In grade assignment 5, to form a 3-digit number with without repetition from 0 to 8 digits.
0 to 9 digits.
0 to 9 digit. You have to do what? Uh,
Form a 3-digit number. It's a question.
okay. Yeah, that is okay. That is easy. Yeah, this one, right?
Yes, I think the options are wrong. Sir. I got the answer, but I'm not able to find the answer I got in the options. And I verified it many times.
Just to form a 3-digit number. So these are the digits for you or different digits? 0 to 5 or anything else?
So I have 0 to 8, and the options are also different. The question
Okay.
is a bit different, just from 0
0
to
to 8. Okay. So have you considered 0 that 0 can't come in first?
Zero not considered, sir.
It's already included for password. That I know. You won't include 0. That I know. Even after that, I excluded it. Then also
No,
I'm
no.
not.
What I'm saying is, let's say if we form a 3-digit number, 0 can't come here.
Yes, sir.
So
Yeah, zero.
The
Zero
first.
से
so that
बोलने का कोई मतलब ही
okay,
नहीं है.
you included this one. Still your
Yes, sir.
answer is wrong.
No, I didn't include it. So I know like you include 0 only in the case of like password. Otherwise you don't. Otherwise if you do, then it becomes a 2-digit number. And I excluded 0. Even after
Mhm.
that, I'm not getting the answer that I got in the options.
Then how to? I mean, okay, maybe then we have to check after this submission deadline is over, I think.
Okay, sir.
Or maybe you are doing it incorrect. Something both uh, possibility you have to see after this deadline. So okay, and doubt and practice assignment. In practice assignment in week 6 sent out activity question.
पर बेसिक से स्टार्ट करेंगे.
Oh, okay. Yes. So first session. When is that? 17. Today is 14. Okay. So fine. Can start, but week 5. Okay, so there are no doubts in week 5.
Yes.
Okay. Then maybe we can close this.
Yeah.
Okay, bye then.
Thank you, sir.
Thank you, sir.
Yeah, thanks everyone.
Ma'am,